All right, welcome to this discussion on trigonometric functions. And this video is going to serve as an introduction into the study of trigonometry. And we're going to begin our lesson with a short video on angle measures. And as you can see from the title, we're going to begin with angle measures in degrees. And then my next video will be a discussion of angle measures in radians. So we'll bring in the definition of what an angle is, and an angle is formed by the rotation of a ray about its endpoint. And what I'm going to do is I'm going to bring in a graphic, and here is my ray. So you can see that we have the vertex at the origin, and the ray is lying on the positive x-axis. All right, and when that happens, when the ray is at the origin and it's lying on the positive x-axis, we're saying that that is the initial side of the angle. And then what we're going to do is we're going to wind up rotating this, anywhere throughout my coordinate plane. We can rotate it anywhere. And the direction of rotation, whether we go counterclockwise or clockwise, is going to make a difference. And you'll see that in a couple of slides. So in this one, I'm just going to rotate it just a little bit. You can see it's counterclockwise. And we're going to wind up in quadrant 2 here. That's my terminal side. And again, the quadrant that the ray ends up in is going to be the quadrant that the angle lives in. We rotated the angle a certain amount of degrees counterclockwise, and the angle stopped in this position in quadrant 2. So this angle would actually live in quadrant 2. We'll get into that in the next couple of slides. So next thing we want to talk about is standard position. What does it mean if an angle is in standard position? You can see by the definition there. A standard position is where the initial side, as I said a little while ago, the initial side is on the positive x-axis and the vertex is at the origin. Okay, so this would be considered an angle in standard position. And the quadrant where the angle lives is determined by this terminal side. So wherever this terminal side stops, that's where the angle lives. All right, so we'll go to the next slide. Now we're going to talk about angle measure. An angle measure is the size of the angle and rotation direction to get from the initial side to the terminal side. So I have my initial side here. We have, it's in standard position. I had mentioned this on the previous slide. It does matter which direction you rotate your angle. So if you rotate, you can see it here, if the direction of rotation is counterclockwise, we're going to wind up with a positive angle measure. So if you rotate your angle counterclockwise, it's going to wind up with a positive angle measure, and it'll wind up seeing from the graphic here. So we wound up going in the counterclockwise direction, and this angle measure, whatever it would happen to be, would actually just be a positive value. All right, and again, since its terminal side is residing in quadrant 2, that's where the angle would live, and you can see it right here. This would be a positive angle because we rotated from the initial side to the terminal side counterclockwise. It would be positive, and the angle, again, since the terminal side is in quadrant 2, the angle would live in quadrant 2. Okay. Now conversely, if here's my ray, and if we were to rotate it clockwise, and you can see by the definition here, we're going to wind up having a negative angle measure. So you get a negative angle measure if the direction of rotation is clockwise, and you can see by this little animation. So we started at our initial position. Our initial side was right here in standard position, and then we rotated it some amount of degrees clockwise, and this would result in a negative angle measure. All right, and again, the terminal side wound up in quadrant 3, so that's where this angle would live. It would be a negative angle measure, whatever the angle happened to be, and it would live in quadrant 3. All right, let's talk about degree measure. So one way to measure angles is by using degrees. That's a common measurement. And in the next video, we'll wind up talking about radian measure. And we'll talk about, full rotation of our angle. So if we had our initial side here, if I just drew the little animation, if I had my vertex here and I drew my ray. Now it's in standard position, and you saw the little animation. If we rotated this ray one full rotation, all the way around, this would result in an angle of 360 degrees. Because we rotated it one full rotation counterclockwise, it would be positive 360 degrees. So a full rotation counterclockwise is a positive 360 degree measure. And then conversely, if we went clockwise, you can see here, if we rotated this negative 360 degrees, you can see this little animation, and I'll draw in the ray again. If I put our initial side again here, and we rotated it clockwise one full rotation, that would give us a value of negative 360 degrees. All right, so counterclockwise is going to result in a positive value, and then as you can see right here, clockwise is going to result in a negative value. So this is just going to be some examples in finding angle measures and drawing them in standard position on the coordinate plane. So you see the initial side drawn, standard position, and we want to find, you can see from the directions here, it says find the measure of the angle in degrees, and then draw the resulting angle on the coordinate plane. So they want us to draw and find the angle measure 2/3 counterclockwise rotation. So we know if we have our complete rotation, it's going to be 360 degrees. And since we're going counterclockwise, it's going to be positive 360 degrees. So we want 2/3 of that. So we want 2/3 of 360. So all we're going to wind up doing, you can see by the text that popped up on the screen, all we're going to do is take 2/3, multiply it times 360, and we're going to get a value of 240. So 2/3 counterclockwise rotation will give us a value of 240 degrees, and you'll see it'll be drawn on the coordinate plane. So we're just going to mark off 240 degrees, and that's exactly what it was. So we just took our initial position, our standard position, our initial side, and then we rotated it 240 degrees counterclockwise, and that's where it would reside in quadrant 3, and that's how you draw it out. We just make our little our notation there that we rotated it 240 degrees, and that's where it would live. And that's really all we're doing. So we'll go to the next slide, next example, and now we want to do the same directions. We're going to draw it, or we're going to calculate it, and we're going to draw the resulting angle on the coordinate plane. But this time we want to do 2 2/3 clockwise rotation. All right, and we know if we're doing clockwise rotation, that's going to be a negative value. That's going to be a negative 360. So what I'm going to do is just change this this mixed number to an improper fraction. You can see that. So that's going to be 8/3. And again, we have to multiply that times negative 360 because we're going in the clockwise direction. So our angle measure, if we take 8/3 times negative 360, that's going to be negative 960 degrees. And you can see what's going to happen here, how we're going to have to draw this. So there's the negative 960, and you can see we're going to have to rotate the angle around a couple of times around the coordinate plane. So we would start, I'll just make a little point here. If we started here, we would have to go around one time, that would be 360, and then we would go around again, that would be negative 720, and then we would have to make up that difference till we got to negative 960. So that's why you have the swirl pattern here when we identify the angle. So that's what you would need to do for angles that are bigger than 360 or less than negative 360. And that's really all you're doing. So one more of these examples, they want us to find the measure of a half counterclockwise rotation. You can see it right there. It came up. So we have our standard position here, and all we're going to do, so we want a half counterclockwise. And again, if it's counterclockwise, it's going to be a positive rotation. So we're just going to take 1/2 of 360, and that's just 180. And then we're just going to draw out 180 on the animation, and that's it. So 180 degrees would be obviously half of a circle, half of 360. And that's what it would look like. And we want to do counterclockwise, so again, the angle measure is positive. Okay? And then we're just going to do a little wrap-up slide just to cover our main points of the video, and then we'll just end the video. So the first thing we talked about is an angle is formed in the coordinate plane by rotating a ray about its endpoint. The initial side of an angle, so the initial side is always going to be with its vertex at the origin, and it's going to lie in the positive x-axis. And the terminal side is the side which determines in which quadrant the angle resides. So wherever the terminal side winds up, that's where the angle actually lives. And we have positive angle measures have a counterclockwise direction of a rotation. So if we rotate that initial side counterclockwise, it's going to wind up being a positive value, positive angle measure. And if we rotate that initial side clockwise, it's going to wind up residing or having a negative angle measure. And that's really it. So again, this was just a very quick intro video into the discussion of trigonometry. And in the next video, we're going to discuss radian measure, and then we'll get into some definitions of the trigonometric functions. So hopefully you enjoyed the video, and I look forward to catching you in my future videos. Please take care.